You ever just click play on a YouTube video and wonder, what's actually happening behind that little play button? Well, it turns out it's one of the most insane, complex video systems ever built. So let's pull back the curtain and see how this machine pulls off the magic of getting billions of videos to you every single day.
So just to get a sense of the scale we're talking about, let's start with a number, 500. Now, that's not 500 videos, it's not 500 megabytes, that is 500 hours of video being uploaded to YouTube every single minute. Yeah, just think about that. Dealing with that constant tidal wave of data, that's the mind-blowing challenge we're going to dig into.
Okay, so here's the game plan. We're going to follow a video on its entire journey, from the moment it gets uploaded to how it gets transformed from one file into many, then how it's delivered from a server all the way to you, what makes the playback so smooth, and finally, we'll look at the AI brains kind of running the whole show from behind the scenes.
All right, first stop, the upload. This is where it all begins. The second a creator hits that button, a master copy, the digital original, is born, and it needs to be protected, like immediately.
The instant that file hits YouTube servers, a few things happen in a blink. First, it grabs the source file, your typical high-quality MP4 or MOV. Then, it immediately validates it. It's kind of like a bouncer at a club checking its ID, making sure the video's codec, that's the compression software, and its resolution are all legit. And then, the really crucial part happens, replication.
To make absolutely sure that original file is never, ever lost, it's instantly copied and shotgunned across multiple Google data centers all over the planet. It's all about creating a super durable, super safe master copy. This thing becomes the single source of truth for the wild transformation that's coming up next.
Okay, so our master copy is safe and sound. But here's the thing, that one single file, it's pretty much useless to most people as is. So now comes the real magic trick, turning that one video into something that can be watched by billions of people on billions of different devices.
And this is really the heart of the problem, right? A creator uploads this one gorgeous high-res file. But how in the world does that same video play perfectly on your phone when you've only got one bar of service and look incredible on a giant 8K smart TV with a super fast internet connection? Seriously, how do they do that?
The answer is this process called transcoding. Basically, YouTube takes that one master file and just goes to town on it. It converts it into dozens of different versions. We're talking different resolutions, from a teeny tiny 144p all the way up to a massive 8K, plus different formats that are optimized for whatever device you're on. This is what makes sure there's a perfect version of the video ready for you no matter what.
But you gotta remember that number, 500 hours of new video every single minute. Trying to transcode all of that stuff into dozens of formats, that is just a colossal amount of work. To do it that fast and at that scale, you can't just throw regular servers at the problem. Nope, you need a secret weapon.
And here it is. This is the secret weapon. This chart says it all. On the left, you've got your standard off-the-shelf servers. But on the right, those are YouTube's own custom-built chips. They're called video coding units, or VCUs, and they are designed to do one thing and one thing only: encode video like a bat out of hell. And look at that performance jump. It's just staggering. We're talking up to 33 times faster than a traditional server. That's a game changer.
And to get the most out of all that power, the system schedules these transcoding jobs across thousands and thousands of servers all at once. It's basically one giant distributed computer. And it's smart, too. It prioritizes videos that are starting to trend, so they get processed first. This whole parallel processing thing is how a video can show up on the site fully processed in every single format just moments after it's been uploaded.
So the video now exists in like 50 different formats. Problem solved, right? Ha, not even close. Now you've got to get the right version of that file to someone who could be thousands of miles away, and you've got to do it instantly. So welcome to the global relay race of data delivery.
The magic behind this is something called a content delivery network, or CDN. Just think about it for a sec. Without a CDN, if you're in, say, Tokyo and you hit play, your request might have to travel all the way to a data center in the US. That long trip is what causes lag and buffering. But with a CDN, YouTube basically stashes copies of videos on servers all around the world. So your request just has to go to the local server right down the road, making playback feel completely instant.
Yeah, a really easy way to think about it is like a local library. Instead of having one giant library for the whole country, a CDN puts little local branches in hundreds of cities. These local servers cache or store copies of the most popular videos, so they're already waiting for you nearby when you decide you want to watch them.
Now, live streaming, that's a whole other ballgame. It's even more intense. The live feed gets sent to YouTube and is then immediately just chopped up into tiny 2-second chunks. Each one of those little chunks gets transcoded and delivered in real time. It's this frantic, non-stop process that allows millions of people to watch a huge event live all at the same time without the system even breaking a sweat.
All right, we've made it from the upload, through that crazy transformation, and all the way across the globe. Now it's time for the final mile, the incredible tech that's working right inside the YouTube player on your phone or your computer. Okay, so here's the magic happening right on your device. It's called adaptive bitrate streaming. See, the YouTube player isn't just a dumb window. It's actually a super intelligent little agent. It is constantly, and I mean constantly, monitoring your internet speed, checking how hard your phone or computer is working, and even looking at your screen size. It crunches all that data and in real time picks the absolute best video quality for that specific moment.
And this is exactly why you almost never see that dreaded spinning buffering circle anymore. Think about it. You're walking from your living room where you have perfect Wi-Fi, maybe down to the basement where the signal is kind of spotty. Before you would even notice a stutter, the player has already sensed that drop in connection and has seamlessly switched to a lower quality stream just to make sure the video keeps on playing without a single interruption.
Okay, last part. Let's zoom all the way out and look at the intelligence that's managing this entire planet-spanning system. Because it's not just about brute force and having a ton of servers. It's about being incredibly smart.
Artificial intelligence is basically the conductor of this whole orchestra. It's not just reacting to things, it's predicting them. AI models forecast which videos are about to go viral, and then they proactively move those files to the local servers we talked about before everyone even starts clicking. It's the brain behind your recommendations, and when there's a huge live event happening, AI is what's intelligently routing all that traffic around the globe to make sure the entire system stays up and running.
And that intelligence, it goes way beyond just speed. It's also about efficiency. Remember those custom VCU chips? They weren't just built to be fast. They were designed to use a tiny fraction of the energy of a normal server. This focus on building their own custom hardware is what makes the whole system not just massively scalable, but also way more sustainable than you might think.
So if there's one thing you take away from all this, it's this. That simple, seamless experience of just watching a YouTube video, it's the result of 3 massive forces all working in perfect harmony. You've got the custom hardware, like the VCUs, the incredibly complex software running the show, and this brilliant layer of AI conducting the whole thing. It is, no joke, a masterpiece of modern engineering.
So yeah, this system delivers video flawlessly to billions of us today. But our appetite for video is only getting bigger, right? So the next great engineering challenge is already on the horizon. What does this incredible machine even look like when it has to serve not billions of views, but trillions?